Hello and welcome to today's video. Some progress has actually been made. You know, there's been a few setbacks. I killed one of the, I killed this processor board. And I attempted to pull the EEPROM off, or the flash memory chip, and I succeeded in decapping it. This conformal coating that they use, I think, is just epoxy. It's very hard. Soldering iron doesn't soften it at all. You kind of have to scrape through, and you can see down here it's still, like underneath, it essentially glued the chip to the board. So it made it extremely difficult to remove. I ended up damaging it. So with the replacement board that I received, I ended up lifting the pins, and that was a very sketchy kind of endeavor to make sure I didn't break the pins, but they've been successfully lifted, and I've hooked up my little board, which is down here, is hooked up to it so that I can now read and write to the flash memory chip. So I lifted the master out, slave in, master in, slave out, the S clock line, and the chip select line. When it boots up now, of course, we get nothing because the microcontroller can no longer talk to the flash memory chip, so nothing even shows up on hyperterminal. And so we've got it all powered up here, and I've got, over here's the, I'm just running a really simple state machine, and then this is the actual EEPROM contents right here, and we're going to go ahead and run it. And I've got a breakpoint beginning of the state machine, and it's, yes, I know it could be a case select, but it's just a if else and else if type thing. So if we run it, you know, we hit state 0, and what it does is actually waits, checks to make sure there's no clock, and of course there isn't, so we're going to skip through there and just keep doing that. Actually, what I need to do is move the breakpoint to a state that is later. Otherwise, it's going to be stuck there forever. There we go. Okay, so we're now at state 20, and we're going to read the EEPROM, and that will populate my array here. So we're going to hit run, and we just read out the entire contents of the EEPROM, including the first 2 bytes here with the checksum, and then that's our 17 that we want to change to an 18. 11 in hex needs to become 12 hex. So I'm going to hit run again, and we're going to modify, and now we've changed it to 18. We've recomputed the checksum, and now we're going to write it to the flash memory chip. So we just wrote it, and we're going to verify that. We're going to read it back. So we read it back. See, we advanced states, but the data didn't change. So we're good there. That was page 0. So now we're going to do the same thing for page 1. So we're going to run again. And you can see this is the second page, and it's still set to 17. And then we're going to modify that. So now it says 18, we recomputed the checksum, and we're going to run again. It's now been committed to the flash chip, and we're going to hit run again. And it read it back out and verified it was good. And if I hit run one more time, we got the green LED. I didn't show you the LED, but it turns flashes red while it's waiting for the if it detects a clock, so it doesn't try to write while the micro is talking to it. But since I've lifted the pins, that's kind of like legacy code from the old version. And then it turns yellow. It's a bicolor LED. It turns yellow while it's writing, and then it turns green when it's done. So right now we're at state 200, which is the last state, so we're done. And if people want this code, I can give it to you. It's not that impressive. It's just really quickly kludged together. But anyways, so I am ready to take all of my mods back out, solder those pins back to the EEPROM, or solder the EEPROM pins, bend them back very carefully, solder them back in, and the next video, hopefully, we won't have that box type mismatch error anymore. So anyways, thanks for watching.